Hi, I'm Haley, and I want you to imagine a man named Mark at a family dinner. He's telling a story he's told countless times, but today he pauses. He can't find the name of the main street in his own hometown. It's a small, unsettling lapse, but it's a sign of a storm gathering in his brain. This memory loss, which millions experience with diseases like Alzheimer's or Parkinson's, isn't just an abstract idea. It's a physical problem. In a healthy brain, proteins do their jobs and float around. But in these diseases, proteins start to misfold and clump together into dense, solid, and toxic plaques, as seen in the top left of this slide. These plaques are like cement, clogging up the cell and killing the connections that form our memories. For decades, we've been trying to clear these plaques after they form. But what if we could stop them from ever forming at all? The problem is we don't know exactly how they start. And that's where my research comes in. We have a new theory. This toxic cement might actually begin as something harmless. You see, when a cell is under stress, proteins do something amazing to protect themselves. They cluster together to form teeny, reversible liquid droplets. You can think of these like water in this analogy. This process is called liquid-liquid phase separation, and it's a normal, healthy survival tactic. The droplets are meant to be temporary safe havens, which should dissolve when the stress passes. But we think these droplets are a critical tipping point. What if they don't dissolve? What if that harmless water suddenly freezes into ice? My project investigates the idea that these droplets are the breeding ground for disease, the place where the liquid state tips into the solid, toxic plaque, or ice state. The two possible pathways I study are depicted in the top right of this slide. In order to test all of this, I'm using baker's yeast. It's a perfect, safe model with proteins that behave just like ours. In my lab, I create these liquid droplets, or the water, in a test tube. Then I add a bad influence protein or a seed that we suspect might trigger the freezing. I then use special dye that glows bright green when ice, the toxic solid, forms. This allows me to watch in real time, and for the first time, actually time the tipping point. Does the water freeze instantly when the seed is added? Does it happen slowly? And can we even stop it? And this brings us back to Mark. If we can understand the switch, the specific seed that turns the protective liquid into the toxic solid, we can begin to design a molecular antifreeze, a compound that could help Mark remember that street name. Imagine a drug that doesn't just chip away at the cement after the house is already crumbling. Imagine a drug that stops the water from ever freezing in the first place. By understanding this fundamental tipping point, my research aims to find a new way to fight these devastating diseases, to stop the plaques before they start, and ultimately protect the memories that make us who we are. Thank you for watching.